Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Topic 5, we are going to discuss about abstract classes and interfaces. So there are two parts here. The first part, I'm going to first explain about the concept of abstract classes. Okay, all this while, in your previous lab tasks and lab activities, we have created a concrete class. Yeah, a concrete class, like for example, you have created a class rectangle, a class circle, a class student, and so on. So those are normal classes. Okay, normal classes that you can create object, yeah, from the class. So a concrete class is where we can create or instantiate object from those classes. However, there are some situations where the class can be so general. Yeah, the class can be so general. For example, you want to represent one particular concept that there is no specific implementation. Yeah, something that is abstract, something that is not concrete, but something that exists. Yeah, for example, you know what it is, but in terms of how it does, in terms of how it is being implemented, that one is has to be done in a separate classes. So how do we provide a class that represent these bases, you know? So this is where we can create an abstract class. So abstract class is a class that can be created only to enable other classes to extend from them. Okay, so remember, when we create an abstract class, we cannot instantiate object, but abstract class is meant to be inherited. It's meant to be extended, so that when you inherit from abstract class, you can provide a specific implementation. Okay, so later we will see example. So if you try to instantiate object from an abstract class, you will get an instantiation error. Okay, so we cannot create object from an abstract class, unlike the normal concrete class. Okay, so under abstract classes, there are two kinds of methods. The first method is non-abstract method. Another method is abstract method. So when you define a class to be abstract class, it can have any of this. Yeah, it may be it can have maybe non-abstract methods. Yeah, non-abstract method is just like a normal method, like what we have done before. For example, public void set name, public string get title, for example. Okay, normal method, sorry. Okay, so an abstract class can have a standard on common method or non-abstract methods, and abstract classes typically, I would say typically, because it is not mandatory, it is not compulsory, but it is expected usually. Okay, usually at least it has one abstract method. So abstract method is a method that has no implementation. It only contains the name of the method. Okay, it has no body, it has no open and closed curly braces. There is no statements in that method. It's just a declaration of. We're gonna see an example later on. Okay, so when making an abstract declarations, if you declare a class to be an abstract class, the method, each of the methods can be abstract or not. So it depends. Yeah, it depends on the class itself. But if let's say you define one of the methods to be abstract, okay, by default the class must be declared as abstract as well. Okay, so when you create a subclass that inherits an abstract method, you need to write a method with the same signature. We need to say that it has you need to override the method, and it must use the same method name as well as the type of parameters used. Okay, so it is required to code a subclass method to override every empty abstract superclass method that is inherited. So this is the reason when we created an abstract class, and when we have an abstract method, that abstract method is meant to be overridden or meant to be implemented. So we need to override those methods. Okay. Alright. Okay. This is an example. Okay, so when you define a class to be an abstract class, say for example animal. So animal, the concept itself, it is an abstract thing. Although there is a concrete animal, of course, isn't it? Concrete animal like a cow or a cat, a dog, and so on. Okay, so let's say we define, this is just to demonstrate the concept of abstract, yeah, the concept of abstract class. So when you define a class to be an abstract class, you must use the keyword abstract. Okay, abstract before the keyword class. So for example, public abstract class animal. So animal is an abstract class. What does it mean by abstract class? Meaning to say that this animal class represent an animal, and there are certain things that you want to define what it is being an animal, but you cannot provide a detailed implementation. For example, in this animal abstract class, there is a method called speak. Okay, because animal it can speak or talk, yeah, but the way they talk may be different, yeah. For example, cow and dog has different ways on how they speak or how they talking, right? So we define an abstract method like this. Okay, so you just have an abstract keyword over here to denote that it is an abstract method. Okay, and the method name and end with semicolon. That's it. There's no implementation here. Okay, so this is an abstract class. Okay, um, and then it has other normal method. This is non-abstract method. Get name, set name. This is non-abstract method. So in abstract class, you can have a combination of, yeah, you can have a combination of abstract as well as non-abstract method. Okay, so when we want to make use of the base class or the superclass here, we can extend from it, yeah. For example, let's say we want to have a concrete class that can be created. Public class dog, look at this example. Public class dog extends animal. Okay, extends animal. So the abstract class is meant to be inherited, and inside this class you are not going to rewrite, yeah, what has been defined in the superclass, because you have inherited all those things, except, yeah, when you extend an abstract class, you must provide the implementation of an abstract method. In this case, the speak method, yeah, must be spelled out, yeah, must be implemented. All right. uh, so this is how we do it. Okay, so when you define an abstract class, make sure a class that inherit from this class must provide the implementation. Okay, right, and this is just a main class, yeah, to demonstrate the use of the abstract class. Okay, now there is a concept called dynamic method binding. When you create a superclass and one or more subclasses, each object of each subclass is a superclass object. Okay, this is for example, when you create a superclass, let's say animal, right? And then you have, of course, one or more subclasses. For example, dog is animal, right? Cow is animal. Elephant is also animal. So they have this is a, okay, because every subclass object is a superclass member. You can convert subclass objects to a superclass objects. So what does it mean here is that when you have a family of inheritance here, inheritance relationship, uh, you can actually use the superclass type to be the main reference. Okay, so for example, your superclass is an abstract. Yeah, when a superclass is abstract, you can indirectly create a reference to a superclass abstract object. Okay, so this one, as there is no problem, because when you define a reference, for example, animal. Okay, animal A, uh, semicolon, you are just referring, you are not creating an object at that point of time. When you are declaring, you are just providing a reference, yeah, but not yet creating the object, right? remember that when you create an object, it has to be from the concrete class. Okay, all right. A reference is not an object, but it points to a memory address. Okay. So although a reference to an abstract superclass object is not concrete, you can store a concrete subclass object reference there. Okay, this is what we're going to see an example later on. Okay, this one. Okay, the concept of dynamic method binding. Okay, we can see from this snippet of codes. Yeah, for example, what it means by the superclass type and all that here. For example, let's say you want to define an object reference, yeah, of type abstract class. So say animal. Animal is actually an abstract class, right? Abstract class. Animal ref is actually an object reference. So this kind of statement is okay, right? What is not okay is if you wanted to create an object of type animal. This is not allowed. Okay, you will get an instantiation error because animal is an abstract class. Okay, but in this case, you see here, although animal ref is an animal, but when you use this object reference is meant to hold the references to the reference to an object, and in this case, you are creating a new object cow, right? Remember, cow is actually animal because it inherit, isn't it? The way you define a cow, public class cow extends animal. Okay, so you can create an instance here because cow is a concrete class, not an abstract class. So this is fine, right? And then let's say you call the method speak, right? Speak. Remember, this speak method is appear it's appear in each of the subclasses that inherit from the animal class. For example, in your cow class, yeah, it has its own speak method, and inside the dog class, it has its own speak method as well. So this is where the dynamic method binding occur, yeah, because when you call the method, this during execution time, okay, uh, it knows already which speak method will be called from which class, yeah, because the dynamic method binding occur during the execution or during the runtime of the program. Okay, so this actually demonstrates the polymorphic behavior. All right. Okay, in this example, there is no superclass animal object created, yes, and none can be, yeah, because you cannot create object from an abstract class. However, dog and cow are created using the new keyword. Okay, so this is totally fine. All right. So assigning a variable or constant of one type to a variable of another type is called promotion or upcasting or implicit conversion. This is fine. For example here, although you created an object cow, okay, but although animal ref is of type animal, this is fine because animal is a superclass. So if this is a subtype, super type, is fine. Yeah, but you cannot say you put it as a cow or dog. Alright, if it's cow, you can only create one specific object from that class. Okay, so here in this case we call it promotion or implicit conversion or upcasting because you can create an object of type subtype because it is from the same family. Alright. Okay, so dynamic method binding, which we also call it as a late method binding. So it allows an applications to select the correct method, yeah, depending on the argument type. So whenever the application executes, when you run the program, okay, the correct method will be executed. How does it know the correct method will be executed? For example here, which speak method will be executed? Because it knows, because of the dynamic binding just now, okay, so it knows that the speak method actually belongs to the methods inside the cow class. Alright, so this one we do not have to worry. It happens automatically. So another kind of binding is what they call it. They call it as a static binding or fixed method binding. Okay, this is another kind of method binding. So in instance methods, yeah, normally instance method, those that receive a this reference. If you can recall in our previous example, we have learned about the this reference, right? They use dynamic binding. However, class methods use static method binding. Means it is the direct one, because static method is defined already inside the class, isn't it? So it is fixed in that sense. Alright, so using a superclass as a method parameter type. Okay, this is the same example like I've shown just now. Okay, say for example inside this main class, this is the main method. Okay, just to provide the demo. So let's say you created a dog object and cow object, right? And set the name of the dog and set the name of the cow, and then you call a method called talking animal. Okay, so this method talking animal, you pass two different objects here, right? You can pass dog and cow, but look at this method declaration. Your method declaration does not use one specific instance, either dog or cow, because if you do like that, you cannot call the same method by using two different objects, because they are from the same family. Remember, this dog and cow both are subclasses of animals. Yeah, because they are subtype of. So you can use the supertype. The supertype here is the animal. Okay, the superclass. So this is totally fine. So dynamic banding occur at this point of time because it knows already. This animal actually representing dog or cow. Okay, it happens during the runtime. So dynamic method binding, most useful when you want to create a method that has one or more parameters that might be one or that might be one of several types. Okay, if you don't declare like this, okay, what will happen is that if you want to call a method talking animal, you would have to repeat this method again, isn't it? Say for example, talking animal dog, right? And then you created a method just for talking animal of type dog, and then another method talking animal of type cow, and then maybe another method. So that is redundant. Okay, that is redundant. By right, we can have this dynamic method binding because they have this inheritance relationship. All right, so by virtue of the having the being the subclass of those supertype subclass of the animal, for example here, okay, you can just create one method that can accept any animal object. Okay, any animal object. Remember the one that I said just previously, the is a relationship. Okay, all right. Okay, so here okay, this is creating an array of subclass objects. All right, this is also to simulate uh, the concept of creating one array, yeah, which is of the super type. Yeah, for example, animal is an abstract class. But of course, although this is an array of type animal, of course you cannot create object of type animal inside to be kept inside this array. Yeah, that is not acceptable because you cannot create an instance of an abstract class. However, we know that animals, there are many subclasses of animals. It could be dog, it could be cow, it could be snake, and so on, isn't it? So we definitely can create those instances inside the animal array. So this is totally fine. Okay, totally fine. So here inside this for loop, for example, if let's say you want to call a speak method, okay, it knows which animal actually it refers to, which object does it refers to. This is where the dynamic binding occur. Okay, this is where the dynamic binding occur. So when you create an array of superclass references, it can hold subclass references. Okay, subclass, meaning to say any of the subclass objects can be stored inside the array. Alright. And this is not only for the abstract class, yeah. This concept, of course, for non-abstract class is also the same. Yeah, the dynamic binding still occur, the same thing. Alright. Okay. Let me stop here for a while.